This equation here is quadratic in form, meaning that it is not a quadratic equation, clearly with the fraction exponents, but we do have a relationship between those exponents that if I take this smaller exponent and multiply it by 2, that gives me that larger exponent. Anytime I have that relationship, then the equation is quadratic in form. And in those cases, we can make a substitution to make this look like a quadratic equation. The substitution that we make is usually with the letter u, and we take u to be that variable expression to that smaller power, so in this case x to the 1/3. Now if we do that, if we look at what happens then when we square u, so if I did u squared, I'd have x to the 1/3 squared, and in that kind of situation there we would multiply the exponents. 1/3 times 2 is 2/3, so I would get x to the 2/3. So over here where I see this x to the 2/3, I'm going to replace that with u squared. So I have 3u squared minus 11, and here where I have that x to the 1/3, I'm replacing that with a u, minus 4 equals 0. And so now by making that substitution, the problem basically just looks a lot nicer. We see that it is a quadratic equation. We can then solve that quadratic equation by factoring or by the quadratic formula. This particular problem can be factored. So we'll go ahead and factor this side. Be 3u times u to get the 3u squared. And a plus 1 here and minus 4 in that second one there. That gives us, when we multiply the outer terms, of minus 12u and the inner terms of plus 1u, and that would make that minus 11u in the middle, and then minus 4 there on the end. So now we'll take each of these two factors separately and set them equal to 0. So go ahead and solve for u. And from our first factor we get u equals negative 1/3. And from our second factor we get u equals 4. So now we have to keep in mind that we were not trying to solve this equation for u. We are the ones that put a u into this problem, and so we need to solve this for x. And that's where we come back to our original substitution that we made, where we have u equals x to the 1/3, and go back to putting this in terms of x. So here where I have a u, I'm going to replace that with x to the 1/3. So I actually have x to the 1/3 equals negative 1/3. And same thing here, I have x to the 1/3 equals 4. So now to get x by itself, we're going to have to raise both sides to the third power. So that way on this left side here where I'd multiply exponents, 1/3 times 3 is 1. So I get x to the 1, or just x. So we're going to have to do the same thing in that second equation as well. So this is going to give us a solution of x equals negative 1 over 27. So 27 is 3 to the 3rd. And here we're going to get x to these, or x equals 4 to the 3rd, which is 64. So we end up with two solutions for x. X equals negative 1/27 or 64. And each of those would work in the original equation if you plugged it back in to check.